Good morning and welcome to the CAD Class Podcast. I'm Josh,
I'm Jake. Good morning,
and
everyone.
nice to have you once again. We're stoked that you're here. We've got some new stuff today, Jake. We've got some new
Yeah,
stuff,
yeah.
new style.
We got a
We
very
we want
busy
to keep it.
schedule today.
Yeah. We want to keep it a little more interesting every week. So if you do show up every
Yeah.
week, yeah, we're gonna drop some tidbits of knowledge here. Ethan, oh man, so awesome to have you, Ethan and Sam. You have a Ethan said we have your permission to start when you're here. Ethan, I was thinking about Ethan the other day. I want to say this really quickly before we make a couple of announcements. But Ethan, I would love to see some live stream of OC Maker Faire. So at some point, if you could give
Yeah,
Jake or I
definitely.
a call and just like FaceTime us or whatever video software you have, I would love like a little quick walking tour since we won't be able to make it down to the Maker Faire OC. And if you happen to be on this podcast or listening, and you're in the area, Maker Faire OC, I believe, is not this weekend, but the following weekend. So, am I missing
If you're in the
anything there,
area, go
Jake?
and check it out. No. I
Yes.
think that sounds like a ton of fun. Yeah.
Yeah. Awesome. Okay, we have some announcements. I think that's where we wanted to start it. We want to get
Let's
started
do some
here.
announcements then.
We have some announcements. So one of the big ones is that we were speaking at City Council in
Ah,
order to accept an award that I believe we can talk about now, although I haven't officially signed anything. So I hope I'm not
yeah.
breaking any contract there. But we went to City Council to speak about an innovation award that we won here in Sacramento. So we are going to hopefully be bringing CAD to some folks who CAD and some 3D printers and some computers
hmm
and some programming and some innovation programming to kids here and maybe adults as well who couldn't necessarily afford to get started with the hobby. So pretty excited about
Yeah.
that.
It's really lovely. I mean, we talk about it all the time on the podcast. We're all about making things as accessible as possible. So saying, hey, if you want to get into 3D printing, there is absolutely no need to spend hundreds and hundreds and hundreds or thousands of dollars on a printer. Just pick up like an Ender 3 for like $160 or find one on Craigslist or go to your local library, find someplace that is as accessible as possible. If you're going, oh, CAD is so expensive to get into it, it's like, nah, just sign up for a free hobby license. There's plenty of really fantastically powerful, completely free CAD software. If you aren't a student or a teacher or a small business and you still want to get into Fusion, then you can just sign up for a hobbyist license. There's plenty of really groovy ways to get into CAD. If you want to learn about it, there are tons of really fantastic resources on YouTube. If you want to take our course, we have our entire book for free on our website, literally the entire thing. Spread the love, share it around to as many people as you would like to. So yeah, accessibility is a big thing. So us kind of leaning into this grant and saying, yeah, we're able to, provide a huge amount of education and hands-on experience to people who may go, oh wow, this is great. I can kind of lean this into, potentially an engineering degree, potentially a technical engineering position. There's lots of really, really fantastic avenues for this to go to, and so we're just so stoked to see where this goes.
Technician, entrepreneur, right? Yeah, I love it. I'm super excited about that.
Yeah,
This is not really an announcement, but how does Jake's sound? Way better, huh,
I think I
Jake?
sound all right. Yeah,
I think it sounds
finally,
way better. Let us know in the chat if Jake sounds
finally got my mic set up.
like a real podcaster now. In other news, we are going to be presenting at Maker Faire. I think many of you may have already seen some of that news. Ethan says you sound great. So at 3:00 on Saturday, I'm going to be speaking about makerspace tools. That's at Maker Faire in the Bay Area. At 11:00, I believe, on Sunday, Jake is going to be speaking about CAD. So we're going to be talking about some of
Yeah,
this stuff. So if you happen to be in the Bay Area and they're planning on going to that Maker Faire or know anybody kind of here that's going to go, we would love to see them at that talk or just meet with them at Maker Faire. We rented a place in
yeah,
Vallejo right across from where they're actually going to have Maker Faire. And we are still talking about maybe doing a little get together for anybody that does show up. So if you are there, awesome. If not, we're going to hopefully do a little bit of live streaming. We'll let you know. It'll have to be probably a Friday, a Saturday, or a Sunday. But we'll do a little bit of live streaming from Maker Faire, hopefully interact with some of the people there so that you guys get a glimpse into what's happening.
yeah. Be a ton of fun. This is my first Maker Faire as well. I wanted to go to Maker Faire for so many years,
This is
and
mine
I'm so
too.
excited. I'm so
Yeah.
excited. My whole life, I've seen all these just like fantastic makers get together, and it's such a cool environment, and everyone is so nice and just so creative. And I'm like, oh my gosh, I want to go to that so badly. And then the year that I saved up money they shut it down. They said, "Oh, this is the last one." I think it was like 2016 or 2017. I was so bummed. And then fairly recently, only like a year ago, we've been in contact with Dale. Oh gosh, I'm completely forgetting his last name.
Doitering.
Doitry, there we go. Well, I'm thinking Dale Carnegie.
Yeah, Dale Carnegie and I, we've been chatting up there.
Yeah, best friends. Yeah, he is Dale. For you guys that don't know, he's the guy that founded Make magazine, also Make a Fair. He is the godfather of the Make of the Maker movement, and he actually wrote a little blurb on the back of our book, which is very, very nice. So he's invited us over, so we'll be giving a few speeches. So if you guys are interested in completely being brand new to CAD and all the fun stuff that you can do about it, or if you're interested in potentially starting your own maker space in a school or a library or as a business, then you can go and check out Josh's speech, because I'm sure it'll be fantastic.
We'll see.
We'll see.
I'm writing it and realizing, how am I going to fit all of this stuff into 20 minutes? Like, could you introduce all makerspace equipment in 20 minutes, please? It's like,
yeah.
Yeah.
Don't use the pencil, you'll cut your finger off. Don't use the sander, you'll sand off your knuckles. Yeah, mills are fine, but they're very loud. 3D printers are great. All right, goodbye. That's all you
Bang.
need.
Yeah.
Then you can move.
Table saw, miter saw it's like the Animaniacs. Did you ever listen to them?
Yeah.
When they were doing all the states and the capitals. I need to make a little jingle for table saw, miter saw, bandsaw. Just memorize it and be like, walk off stage like, thank you.
And everyone's going, the hell was that? I'm kind of trying to get more information about it.
We wanted to learn something, and he just gave us a jingle. So
I mean, it's catchy as hell, but a little bit unnecessary.
Yep. Where did I just put my piece of paper with our agenda here?
Come on, Josh. We're supposed to be professionals.
Oh, what the heck? Did it fall? Okay. Well, we're going agendaless. Oh, here it is. Here it is. Okay, so we have announcements. Anybody in the discussion, we always like to, if you're new here, first off, welcome. If you are new, please put a note in the chat. It looks like a bunch of you already have. But if you're new, we'd love to know where you're calling in from. And if you're working through the CAD class curriculum, where in the program you are. So where are you in the program right now? And where are you calling from in the world? So we'd love to know. And if you have any questions, please do put them in the chat. We will try to answer them live. We will broadcast Jake's screen. By we, I mean he will broadcast his own screen, and I will watch. So anytime you have a question,
you'll sit there and look pretty. Josh is the face. I'm the brawn.
No, you're the voice. You're the voice. You've got that. Oh, beautiful. So we said we're going to do something new today. We want to keep this fresh. So what do you got for us, Jake?
All right. So one of the things that obviously we both like to do is 3D printing things that are mainly functional. Trying to say, hey, I'm coming across a problem and I want to find a solution. And more times than not, 3D printing actually is the solution, because it needs to be hyper customized. It needs to look kind of neat, and it needs to be super dimensionally accurate and potentially have like a bolt go through or a magnet embedded in it, or multiple pieces that click together, or has some kind of smooth or have a certain color to it. And 3D printing is, for what I've experienced, pretty perfect most of the times. You just have to be really creative and kind of have a good bit of engineering bone in you to kind of get going on it. And one of the things that I have been asked to make by my fiance is the project that we're going to be making today. So very recently, we have brought out this bread making machine from the depths of my storage that I had probably 10 years ago. And we tried to make bread with it, and we just heard the motor go, wah, and then nothing was happening. And then the bread we got out of it was so dense and so awful. And she was like, hey, look, every time I kind of shake it, it sounds like something's rattling inside, and all these like brown and white rectangles are falling out of it. I was like, what is this? And I'm like, oh, I bet that's a timing belt. So we cracked it open. The rubber in the timing belt had completely disintegrated. So we cracked on a new one, made a bread. It was perfect. It was fantastic. We've been making one, like just a nice little loaf every day. Lovely. But we're both really terrible at carving nice, equally spaced bread slices. So I really want to make a little 3D printed jig that has got slots for a bread knife that I can actually then make perfect slice of bread every single time. That's the plan. And I think I can 3D print it, because I'm going to be flying up to Josh in Northern California. I kind of want to print this now before I leave tomorrow. So that's the plan.
So let's set the scene here. Did you take any measurements beforehand? Like where are we starting from right now? Okay, so give us what you know right now, kind of. So you already investigated the problem. You've already come up with this solution that you want. What else?
I've figured it out in my head. So kind of fundamentally, the dimensions that I need. So I've measured the kind of pan that the bread loaf sits in. So I have the width, the height, and the length of the bread that's going to be happening. Then I'm going to be, then I have the actual bread knife. I've got a pair of calipers so I can measure the thickness or the kerf of the blade. That's a technical word for the day. I just looked up exactly how thick a slice of bread is supposed to be. Apparently 13 millimeters is about right. And I know this is going to end up being like 7 inches tall. And obviously it's going to kind of look like a comb where it's got all these kind of slots in there. And I'm imagining that these are going to be pretty flimsy and they can break off. So I'm going to do a little bit of engineering structure to it, just so it can be a little bit more solid. And as far as like basic construction, I know from like a side profile, it obviously has to have a base, it has to have 2 walls, but then I want a little kind of end stop on one side so you can always butt up, the rest of the loaf up to it and get a nice clean slice every time.
Got it.
Yeah. So I think that's the plan. Can you think of anything else that I would need to do for this?
No. I just wanted to kind of set the scene for anybody here who's going to be making their own stuff to kind of like, this is everything we've done before this. So you haven't actually sketched anything on paper.
No.
It's all just living up in your head, and you've taken a couple dimensions, and you know roughly what you want to achieve, and you think you know roughly how you want to achieve it. Awesome.
Yeah.
Let's see what you got.
I think this is a big part of when people really get very good at CAD and they get very good at 3D printing as well. And I think it's kind of being able to understand the downside and the upside of 3D printing and go, okay, well, I can't design something that would be 3D printing in the same way that I would make it out of wood. Therefore, I need to come at it with a little bit more design. It needs to be just slightly different. And I think that's a fantastic way to kind of recognize, hey, I'm at now the next level of my CAD education. I can design things in my head and then 3D print it, and I know that it's going to work because I've now got enough experience for it. Oh, I don't have a bread recipe for this machine. You just throw everything in and turn it on. I will say, if you guys are interested in bread, the bread Bible is called Flour, Water, Yeast, and Salt. You guys need to pick it up. It is the best bread I've ever made in my life. It's fantastic. Anyway, I think we should get going on it then. Let's do it. All right.
I'm going to make some comments, derogatory.
Oh, good. Thank God.
My favorite, I'm going to pop in, especially as you start to design things and tell you how you're doing it wrong. I would do it better if I ever did it, but I never will because I just wanted to tell you you're doing it wrong.
Oh, fantastic. Okay.
First, the inception. Yeah. Go ahead and blow that screen up.
Okay. So I think the first thing that I want to do is kind of make the pattern for just one section, just one kind of sliver that has got all of the parts to it, and then essentially use a rectangular pattern in just one dimension so that I don't need to make like a bunch of cuts in it. I can just make one piece and then pattern it all the way over. And this is going to be something that is totally made on the fly. So I'm very likely to make some mistakes. That being said, I literally just took a picture of like my tape measure in this bread pan. So I'm totally making this up as I go along. I'm sure I'll be making some mistakes, but that's kind of the fun of it, I think. All right. Oops.
All right. Minute 14. Let's see what you got.
All right. You see how good I can do it.
Yeah.
All right. So I am. Oh, whoops! I actually started off totally wrong. So my main design concern with this is that all of the thin section, the thin verticals, I actually want to add a little bit more support to it. So I'm going to be adding a little bit of a bulge that goes outwards to give it just a little bit more of rigidity. Kind of looks like a capital T coming off of it. So I'm going to be starting on the top plane, and first things first, I'll kind of make something that is totally coincident to the origin.
Okay. Yes, it is. PC Van Vliet. A mistake is an iteration. That is right.
Yeah.
Although we had some wacky. I'm just going to talk briefly while you're doing some things here. We had some wacky teacher discussions where they started to encourage people to make mistakes in a really strange way. Like it was all about celebrating mistakes, and it's like it got kind of weird for me. I don't know if you felt the same way. We taught this a while back, and teachers became obsessed with making mistakes.
Yeah, it's like I recognize the importance of it. Like I'm totally down with it. Like not degrading, when people make a mistake, that's perfectly fine if you learn from it. But there's a little bit of the messaging that like encouraged making mistakes. I'm like, no.
Yeah, no, that's
you should
the
be
point.
trying to
you do make
not
them, but
fail.
it's like exactly. Aaron goes, oh yes, we don't make mistakes. We have happy accidents. If only we had the Bob Ross voice.
Yes.
Then yeah.
All right. So a big part of CAD, being an engineer, is that you, a lot of times for design that isn't really hypercritical, I'm just making a bread cutting tray. I literally work with my calipers in hand, and no joke, I've talked to dozens of engineers, and this is literally what they do. They literally just hold their calipers and kind of move their dial, and they go, yeah, that's about right. And then that's what they do. That's literally all they do. All right, so I'm going to make this, I think 15 millimeters. I think that sounds about right. That'll give it some support. And then so this is going to be a top-down section. So you can imagine the blade coming in on the top and the blade coming in from the bottom. And I'll be mirroring this on the other side as well. But the thickness of this is actually fairly important. So I'm going to be making this. You always want to make the walls of a 3D print multiples of double the nozzle size. So most 3D printing nozzles are 0.4 millimeters. And to make sure you don't have any gaps on anything, any walls you make should be 0.8, 1.6, 2.4, 3.2, 4.0, etc., etc. So I think 4.0 millimeters will be should be perfectly thick for this. So you can see that everything else except for the left and right dimensions are defined. So I'm just going to jump into my photo and say, what is the width of the bit of bread? And it looks like it's going to be about 5.25 inches. So I am just going to say, all right, I'm just going to do a little bit of math. So 5.25 times by 25.4 for the metric conversion, and then divide by 2 because this is halfway. Yeah, this is literally how I designed things, as imperfectly possible. Then I'm just going to make a little mirror line so I can extrude both these at the same time. Make that construction line. I'm going to be mirroring all of this across that line. There
Sam's
we go.
daughter is on a sourdough kick right now. Awesome, awesome. I love sourdough. It's so good.
I am also actually no. I'm also going to be putting in some fillets in here for strength, but I'll do that in a little bit. So I'm going to be extruding this upwards. Let me go ahead and check exactly how tall this loaf is.
By the way, if you're in here now, please do hit the like button. Make sure you subscribe to the channel if you're not already subscribed.
Yeah. Does that look like it's going to be strong enough? I think I might extend that out just a little bit more, maybe 20 millimeters. So because this is going to be printed in the vertical orientation, all the layer lines are going to be horizontal. And so the smaller that you have your cross-sectional area, this face right here, the more likely it's going to snap off. So this is why kind of beefing out this area is really going to make your life a lot better. So I might actually double this. I might, or not double it, I might go 4.8 millimeters just to give it a little bit more heft. I think that's probably the right thing to do. And then for this section now, I actually have my 2 walls. Now I'm going to be patterning them to the right. So I can use the rectangular pattern. These are just bodies, so I can just select both of them. The axis that it's going to follow is along this length and move it along. So my distribution is not extent, because I'm not worried about the entire length of this bread box. I'm more concerned about the spacing of this, because I want to make each of these bread slices to be 13 millimeters. I only care about having them in one dimension. But it isn't 13 millimeters. It's 13 millimeters plus the kerf of the blade. So the kerf, K-E-R-F, that is the technical term of the thickness of a blade. So if you're working on a table saw in woodworking and you've got an 1/8 inch thick blade, when you're cutting, it's going to be removing that 1/8 of an inch. So this is looking like it is 2.12. So I can add on here 2.12, and then I also want to add on a little bit of a tolerance in 3D printing. If you want something to be kind of a nice, tight, snug fit, you want to add on 0.5 millimeter. If you want something to be a sliding fit, you want to add on another millimeter.
Drop in those knowledge bombs. Ethan asked really quickly, if you didn't know the conversion rate and wanted to convert one dimension, does Fusion support something like 1.5 IN or 1.5 inches? It does.
Absolutely.
So if you're designing your project in millimeters and you want to use inches, just type in IN after the dimension and it will automatically convert that into millimeters for you. That is a great question.
Yeah.
Yes, absolutely.
The other big thing, so the other thing for that is when you type in the dimension, let's say 5 IN, and it converts it to millimeters, it will display it on your sketch as millimeters. But as soon as you double click that dimension to edit it, it will then show you 5 IN. So it's never going to convert it to like 300 some mil. Okay. So let's say I'm making this.
So PC Van Vliet says we use mixed dimension in the book. Yes, we do. And if you're new, we are watching as Jake makes something live and drops a whole bunch of knowledge bombs. Take it away, Jake.
Thank you very much. Now comes to the point where I actually know exactly how long my bread loaf is going to be. It's going to be about 7 inches. So I actually am just going to do a little bit of math. So I got my handy dandy TI calculator. So 7 inches times 25.4, that'd be 177.8. I'm going to be dividing that by the width of all of our patterns. That's 13 plus 2.12 plus 1. So it's going to tell me that I need 11 for these slices. I have 13, so I'm going to knock that down to 12 just so I have a little bit of extra room, a little bit more stability. That's just fine. And I can click OK, and this will add in all of these bodies. So these are looking perfectly chunky. I actually feel pretty good about this.
Perfectly chunky.
Oh, yeah. What I actually want to do, which I forgot, is I actually wanted to add some fillets onto this. As with all manufacturing, regardless of its woodworking, metalworking, 3D printing, laser cutting, does not matter. Never keep a sharp corner on your final product. If it is going to break, that is where it's going to break. It is called a stress concentration zone or a stress riser. They are not your best friends. If you have a wooden box and you drop it on its corner and it's got sharp edges, all of the stress from that impact is going to be concentrated on that corner. But if you add a fillet, if you round off, if you add a radius to that, then it's actually going to be projecting all of the forces in more of a 3-dimensional manner. So I don't want to highlight all of this and add fillets, just in case I want to change it. So I'm actually going to reverse my timeline back a step. I'm going to add fillets, actually not to all of this, just to the top sections. Whoops. Just to the top sections, and I'm going to hold down Control or Command and uncheck these. Just add it to the top. Great. And then I think this can be a 1 millimeter fillet, or maybe a 2 millimeter. Basically just going until it gives me an error. So what it's going to do is add in, it's going to take off some material on the outer edges there, which is actually to my benefit, because now I've only got this little strip of surface area where my blade is going to build up friction. So it's reducing friction there, but it's also adding some gusset to this inner edge. So hold down Control, you can see this inner corner. I've now added material to that. So it's going to make it much stronger. So I'm adding this to the top just so it's a little bit more comfortable to kind of put a knife into this slot, but I don't want it on this bottom edge right here. So as I hold down Control, you can see I've deselected this face, but I haven't deselected all of the edges on there. So I can actually just go in there with Control or Command held down and just unselect all of those edges. Oh, it's still putting it on. That's kind of funky. Huh, okay. Forget that. I'm just going to undo it then. All right. Let's add on 2 millimeter fillet. There we go. Holding down Control and just going all the way around and adding it. Fantastic. And I'm just going to do this on the top face as well. Great. And if I was smart, I would have mirrored this in the 3D as well, so I didn't have to do all of these fillets twice. But
what do you mean you would have mirrored it in 3D?
So because I already have another one over here, there's actually no need to add these fillets twice to the other one. I could have just mirrored this part across the vertical plane onto the other side, but that's all right. So that looks just fine. I just want to double check that I've got nice, neat, square edges on the bottoms. Perfect. All right. Lovely. So now when I pattern this, all of those fillets are going to be applied to the rest of them. Wonderful. Okay. So now I want to build up just a little bit of a base to join all of it together. So I'm going to go into create, or actually, yeah, just going to make a sketch on this top plane right there. I can very simply just make a big rectangle, but I want to make sure that it lines up nice and neatly with this top edge right here. So this is where, again, we're going to be using the project tool. This is an area that causes a lot of confusion for a lot of people. So I want to make this top edge totally tangent to these arcs right here, but I can't click on it because I've already made a sketch over it. So by using the project tool, I'm taking information from this body and projecting it onto my sketch that I have. So I'm going to do that one and this one, and then the bottom two down here, and then click OK. And now I actually have clickable points. So I can say, all right, this line is now coincident to that piece. And then same thing over here. So it's just nice and neat. Great. And then I'll do the same thing. Oh, actually, I want to leave this section just a little bit longer because, like I said earlier, I wanted to make a little end stop for my loaf, so I can always push it up and then make more cuts, and everything is nice and even. So let's say I want to make this 10 millimeters. There we go. I can hit finish sketch, and I'm actually going to extrude all of this downwards, but I'm going to leave this open just purely as a design point. And we'll pop it down, let's say 5 millimeters. There we go. Let's go 10, make it a little bit thicker. Does that look too chunky, Josh?
No, I think I like it.
Oops. Hold down control, make sure those pull down as well. All right. Ooh, I'm seeing a little, oh yes, aha. There we go. I need to collect those as well. Because we projected it, they are now a separate entity. So I want to make sure that I include that. All right. That's looking great. So this is most of the bread tray already done. And so then I'm just going to go ahead and make a little end stop right there. So this can very simply just be a rectangle that's all the same thickness. So everything is nice and uniform, 4.8 millimeters. I'm going to be projecting that edge right there, so everything is touching. We'll make this edges collinear on both the sides with you. Thank you very much. Wonderful. All right, and then I'll extrude this section up as well. I'm not sure how tall it really needs to be. Maybe 25? I don't know. So the nice thing about Fusion is that it has so many different ways to enter in the same information. So for example, I'm in a scenario where, these dimensions, they really don't need to be hypercritical at all. And so, typing in this is great, but just having this arrow just to kind of give it a little bit more realism where you go, that's too tall. I don't really know what I'm looking for. That looks about right. That is not a feature that comes up very often on other programs, which I actually really, really love. Really, really love that. The Fusion put that in. Okay, so then we'll add on some fillets, but I actually don't like that this is overhanging a little bit. So I can just cut that face down. So it's nice and flush on that end. And then everything else is kind of smooth except for this block on this end. So I'm going to be adding on some fillets. Again, this is a really common thing that people run into a lot. If you type in a dimension for your fillet and you add one, you can't actually then click on more and more and more until you hold down Command or Control That is the trick. Then you can add multiple of them. But we can see right here, this is actually throwing a bit of an error. And it's probably because it's running into this other wall. So, it doesn't like that. So what is the solution there, Josh? What do you think we should do?
I was not paying attention because I was responding to the chat. What was the question?
Okay, so I can add in some fillets on either end here. But when I try and add a fillet to this edge right here,
Yes. Yep.
it's throwing up an error because this wall is running, or it's actually joining to this face right there. What should I do? Oh, that's a funky one. They're in there as well.
Are those? Wait, so those are joined. It's seeing those as joined.
Yeah. So this face right there, this little strip.
Yep. Because you projected it.
Yep, and this face, because they coincide, they exist in the same plane. So I could add just a little spline of material right there. So instead of making it, absolutely perfectly butted up against there, I could kind of pull it away a little bit. Is that what I want to do? I'm actually going to undo a couple of that and actually work that into the design then. So for this,
Dan Lee says, add an extra fillet in a separate action, make it smaller. Ethan says, extrude as a new body, add fillet, combine.
Yeah, you can do that. I think I kind of want the design worked into it a little bit, though.
What do you mean worked into it? Like where it's connected?
Yeah, a little bit.
Why is that?
Purely design.
Just cause.
Just cause. Just cause. Yeah, 4.8. I don't know. This is purely experimentation for me. So I'm going to make another plane. I think I might continue it off of there. I think that could look kind of groovy. So let's project. Let's project these curves and then make a nice tangent, some curvature off of that. Great. Everyone's suggestions, though, they were all absolutely correct. I know I sound like a broken record, but there are more than one way to skin a cat. So all of you guys' suggestions.
It's more than one way to cut a piece of bread.
I saw one of those like weird fun facts where it's like, when people were born and then inventions that came afterwards. And someone's like, oh yeah, Betty White was born before sliced bread. What?
No.
Yeah. Really strange. Like there's a bunch of things that are way more recent than anyone expects. Like I think we have a few congressmen in the US that were born before the invention of the chocolate chip cookie. Isn't that bizarre? Yeah, I know. It's so strange. All right. So I'm just adding a little 3-point arc over here, making it coincident with this wall, and then I'm just going to add on some tangent constraints. So this is something that is obviously completely not necessary, but it's just something that I think we as makers just like to do. If I'm ever making something where I don't feel 100% solid with the design, I actually hate it. And so I usually put in a weird amount of extra effort to make sure it looks neat, even though no one in the universe would ever care that it's a bread box that's so accurate. But I just kind of like it.
I agree. Gotta add those unique touches.
Yeah, I think there is quite a lot to that. Is it Van Gogh that said all artists just abandon art?
Yeah.
I think all makers secretly hate the things that they work on. Because if I'm
it's never as good as you hoped.
No, I don't even think it's that. So I'm just kind of hearkening back to when I used to do a lot of wood turning, like making wooden bowls and wooden vases. And it's this really strange inversion because if I spend a huge amount of time working on a project, then I'm putting in more, or it's more likely that there's going to be errors and small things in there that I actually don't like so much. But then if I spend, less time on it, then obviously it doesn't look as good. So it's this constant duality of going, there's so many things in there that I know people actually won't notice until I point it out. And they'll go, oh, I think it's fine. All right. There we go. I think I like that design a little bit more, where it actually leans into the curvature of this. And then let's try and put on some fillets. So let's say 2 millimeters.
Nice.
There we go. That looks
No
nice
more
and neat.
yelling.
Lovely. That means that the first slice is going to be just slightly thicker. I think that's fine. I don't think anyone minds the first slice being a little thick. All right. And then just design-wise, again, these little areas right here, I actually don't like them all that much. So I'm just going to select them. I don't think, we don't have it on the other side, so I'm just going to extrude those downwards. And click OK. There we go. So now that's looking fairly neat. But again, we do have some sharp corners right here. All of these verticals, they are going to be wobbly, So adding a little bit of extra strength down here at the bottom is actually hyper critical. So I'm just going to go ahead and click F for fillet. And I'm just going to put a fillet on the entire bottom face. Let's see if I can bump that up a little bit. Oh, whoops. Yeah.
Yeah, and so Aaron says, a quote stands out to me about spending outrageous amounts of time working on insignificant details. I should say Aaron, or if you've seen Key and Peele, Aaron. Aaron. It's from the director's commentary on Monsters, Inc., sanding the undersides of the drawers. Yeah, I'm a big proponent of those finer details, of making things that even people will never... It's like, I think it does make you think that when somebody takes the care to do that, that the rest of it was made well. There was a lot of love and care put into that. So I love that.
Yeah, definitely.
I actually I love it a little too much. We used to teach kids how to build skateboards, and I would go insane teaching them how to correctly sand and getting all of those crappy milling marks out so that their boards were as perfect as they could be.
Definitely. Absolutely. All right. I actually have something else that I want to add to this. So I actually know that I want the knife to go slightly deeper. So I actually made these fillets just a little bit too close. I want to make just a little groove in them that can go slightly deeper than the base. So I'm actually going to knock this back to 1 millimeter. I'm going to make another sketch on this top surface. I know it's so funny to a lot of people that are not in our kind of fun maker community. The idea of spending this much time like designing your own bread cutter is like borderline insane. And I agree. I completely agree. It is absurd, but we like it, don't we?
We do.
There's
Aaron says I'll be living with Key and Peele for the rest of my adult life. I'm sorry, Aaron. I'm sorry. Never again will I make that joke to you.
I feel that, Aaron, because anytime someone introduces me as Jake, they always go, "Oh, Jake from State Farm," and it's like I've heard that joke probably thousands of times, and I'm so sick and tired of it. So I feel your pain, man. I don't know if this is right or wrong. Maybe someone in the chat will actually know this. I heard a rumor. I have not looked it up, but the original actor, the guy that comes down the stairs, did he murder his wife or something like really horrible? I don't know if I make
what?
I heard from someone that in the State Farm commercial where the guy's coming down, and he's like, "Oh, Jake from State Farm." Someone told me, "Oh yeah, the husband and wife in the commercial, they were actually husband and wife in real life, and then like he murdered his wife." I don't know if that's true or if that's totally made up, but someone told me that. I was like, "That's wow, that's awful."
Now I hate this even more. Now I have this terrible association.
Yeah, I know. I have no idea.
Aaron is loving all the details. So Aaron's loving all the details, and he says he embraces AA Run. So you know what? It's just gonna be AA Run from here forward.
All right. Okay. Maybe that's what I should do as well.
He's He's a bigger man than you, I can say.
That's true. Okay, and then I just want to add in a couple fillets to this area. Let's see if I can put in one. Nope.
If you're new, I want to know what you think Jake is trying to make right now. So if you just joined us and you have no idea what Jake is making, please put a comment in the comment section of the live chat. Tell us what you think Jake is trying to make right now.
Oh, whoops.
So you can wait until he zooms out a little bit if you can't see.
Oh, I accidentally clicked somewhere incorrectly and it selected 100 or almost 1,200 facets.
Oh,
whoops.
Good.
Don't do that. Click carefully, everyone.
Look at that attention to detail.
I know. It's so silly because I'll catch myself sticking my tongue out as if like this is super important. I'm like, yes, it's very important. I get this exact fillet perfect. It's like, it doesn't matter, dude. It's all right. No one is ever going to notice this in 1,000 years.
Matters.
It kind of matters a little bit to me. Okay, so now I've got this little valley for the knife to go in just below the surface to guarantee that I've cut through. I've added some fillets on there for strength. I've only made one because I know this is a patterned thing, so that I can go back here in the rectangular. I'm not actually wanting to pattern the body. I only have one body, but I actually want to do the features. So I'm going to do this cutout, which made this little gully, and then the fillets that made that up. For the axis, I actually just want it going along the length of it. So I can click any of these lines. It does not matter. I like to pull this arrow out just so the program kind of knows I'm going in that direction. I think we said 12 for the quantity. Then what was the spacing? Oh, gosh, completely forgotten spacing. It was 13 plus 2.12 plus 1. Oh, whoops. Plus 1. Yep, minus 1 because we left that gap. Perfection. Lovely. All right, just solving that. Great.
Albie was pretty close. It says, looks like a cheese or hot dog slicer. Yeah, it is a hot dog slicer. It is also a cheese slicer, but its primary function is as a bread slicer. So
It's a bread slicer for my fiance.
It's a slicer.
Yep. Spending an absurd amount of time on this as well. Can you guys think of anything else to put on this? Oh, what would be nice? Bread slicing. Is there any jokes? Is there any like decent jokes to put on this? I've heard from a lot of CAD designers, they put an Easter egg on every single CAD thing they do, even if they give it to like a client. There's always something small in there. Wow, that's great. No, I think this will be just fine. I'm gonna go ahead and save this under my 3D prints folder. Bread cutter. There we go. All right, save that up. I think that's looking rad.
All
right.
It's going to be wide enough for your loaf?
Yeah, right? Yeah, because we did the width was like the radius on the first sketch.
Okay.
Then we extruded the height, and then we patterned it for the length. Yeah, we're all good.
All right, looks great.
Josh, don't do that to me.
You gotta put your bread in there. Next week, we're gonna serve bread live on air.
I was genuinely considering like, hey, love, do you wanna keep this bread cooker in my office? You know, just so we can like as I'm working, it smells of lovely bread. And then I put my hand on the top. I was like, oh my god, that is so hot. Never mind. Well, this is hot enough. All right, I think it's
reinventing sliced bread. Ethan says, yeah, that's right.
Yeah,
not messing around.
Not messing around at all. Okay, I'm digging it. All right, I think this bit of the project is done. What time is it? Oh, 10:15.
Not bad.
Lovely.
Yeah. So what time did I say we started? I forgot.
9:30. So we got 15 minutes left.
Next week we will definitely show you the results of this experiment. Although we'll be at Maker Faire, so
yeah.
I don't know. We probably won't have the physical object with us next week. So
no.
I'll following week.
I will very likely print this. Maybe make a little time lapse and
Oh
then put it as a
yeah,
YouTube short. Yeah.
that's
If
great.
none of you guys are subscribed to us on YouTube, then you guys are missing out. We post 3 Fusion 360 tips and tricks every single week. You guys can take a look through all of them. I think we've made over 50 at this point. I think so. We've got lots and lots of really good stuff coming down the pipeline as well. All right.
Cool. All right.
I think this is all done. Yeah, give me some more. Give me some more questions.
More questions.
You guys in the
We
chat.
had in the chat. If you have any questions, please let us know. Sam, it was nice to have you joining us. Sounds like he's got some customers in, so awesome for you. One thing that came up, which we haven't really talked about, it seems like a lot of people are making their way through our program now, but it was on the fire piston. So Toolman Tim posted he's having a couple issues where his piston is not stopping when it hits the body. And since we've not talked about that yet on this live pod, I figured we'd talk about contact sets.
All right. So let's pull this in. And then can we update this as well? Yeah, sure. Okay. So for you guys that aren't as far into the program as, is it Toolcrib Tim?
Toolman Tim. Yep, in the Fire Piston project. Yep.
So this is going to be in chapter 6. This is the first project in the assemblies. So up until now, essentially all of the projects that we've done have just been one object, one thing. And so from chapter 6 onwards, basically half the book, we're now starting to make multiple pieces that then fit together to make an assembly. In the world of Fusion 360, we are saying that each part that goes together is called a component, and components go together to make an assembly. So if you guys look at the browser on the left-hand side, each of the components, its icon is a white cube, and then the assembly is a bunch of white cubes stacked on top of each other. So that's the iconography for it. Anytime you're talking about multiple pieces that are put together, you're usually adding joints in between all of them. And just because how Fusion exists, if you have two objects that are just kind of free floating in the universe, they can actually pass through each other. They can clip into each other, because it's kind of assuming that what you're making as CAD is going to exist in real life. And so you aren't going to have two things merged through each other in real life. You are going to eventually put on some joints. And so it just allows you to push things through either just for whatever reasons it wants. But what you can do, which is quite nice, is go into assemble, and you can enable what's called a contact set. You can kind of think of it as edge detection, where it knows that there are 3D objects that have boundaries, and when they hit into each other, they actually touch. They actually will push one another. If you go into this, where you have a grounded object with a rigidly joined object to it, that means those are concrete and they're not going to move. Then we have a slider joint on this side, and as it goes into the piston cavity, it then stops. So if I get a little bit closer view, it's a little bit of a gap on there, and then it will actually touch and stop, and it can't pass through it. So the way that you would actually put this on there is by going into the assemble and saying, I would like to enable contact set. Then you can come into the browser, and you can then select all bodies contact. So then when you move, it actually does stop. The funky thing about this, and I'm not 100% sure why it's so computationally difficult, is that it has a lot of trouble working with huge assemblies that use this. So if you're working on a small little project that has only a handful of components, I think it has like 6 components, it can deal with this just fine. It's not a problem. But as soon as you have gigantic projects that have got maybe 12, 20, 30 components in there, it really starts to bog down. I've got a super duper fast computer that I just got like a month ago, and if you try and make the gear train project that we have in chapter 10, when we work on motion animation, it will hold down to a slog. It will not work. So contact sets are, I wouldn't use them on every single project. I'd basically just use it on just a couple of components that you know are going to be touching, so that you can show someone and then you can turn it off. That's why in the browser you can turn them off very, very quickly. And then you can see they actually do pass through one another. So much faster, very responsive. And then as soon as I turn it on, it gets very slow.
Yep. So PC Van Vliet says, how would I use a set of digital calipers to measure something with a loft? For example, the titanium hex drivers you find on the internet. Should I use something straight and
The
measure
titanium hex drivers.
Titanium hex drivers. We need a photo
Mm.
of titanium hex drivers.
Can I just rant just for a quick second?
Yes.
Okay. I, much like a lot of tool people, we collect the 1/4-inch drivers for like number 2 Phillips, naught Phillips, 1 Phillips, Torx head, security Torx head, all of them in their different sizes, posi drive, number 1 posi drive, number 0 posi drive, all of them. How come just a normal socket, just the hexagonal socket, the 1/4-inch drivers for those are so hard to find? Why are they so hard to find? They're one of the most common bolts in the world. And I'm like, I just have to deal with like an Allen key I got from IKEA. Like, this is not good enough. Most people have drills. Just give us a little hexagonal driver. I couldn't find any on Amazon that were at a reasonable price. I got a set of mine from like AliExpress, and they're fine. They're totally fine. They do the business. Why is this so annoying? It's like you can find if you go to like Home Depot or Lowe's and they have like a big multi-pack with like 100 different drivers on there, they'll give you 5 number 2 Phillips because you lose those all the time. They're the most common screw head. Completely acceptable. That's great. Please give us a small set of H drivers, please, for the love of God.
So PC Van Vliet follows up and he says most of them have the same dimensional features. I would like to measure up the whole handle.
Of the whole handle. I'm just going to stop sharing my screen really quick just so I can search this.
Yeah, pull up a photo.
Titanium hex drivers.
Yeah, no, I was trying to search for it briefly here. If you've got a nice photo of one, put a link in the chat.
Yeah, and we'll absolutely check it out. I'm seeing a bunch of things that I actually don't know what they are. Prometheus Design X. I have no idea what this is, man. You stumped me. For a loft. Lofts are really funky because they obviously are an organic shifting between 2 profiles. So the best thing you can do is just try and measure the very tippity top of it and the very bottom of it.
Biggity bottom.
Biggity bottom. And just try your best. Generally, if it is a tool of any kind, it will probably have to follow some kind of very specific designation, some kind of classification, whether it's like a European designation or something like that. So if you know exactly what size it is, you can probably get stupid accurate dimensions on it, and you don't even have to measure it.
So the first thing is maybe don't even try the calipers, just see if you can get the dimensions online. I still want to see a photo of it. So PC Van Vliet, if you can find a photo, if you can find a link to something, let us know. And I would love to poke around and look and see what you're talking about. I think it gets to the heart of how do you measure complex surfaces, right? I think that's kind of right. So a lot of it you just model, and I guess if you've got a 3D printer at home, you can model it, kind of eyeball it, get it as close as you can, 3D print it out. It doesn't take all that long to do it. I will often 3D print a piece of something. So if it were the handle, I might just 3D print like a 1/4 of an inch of the handle, and then compare it to the handle that I have. So most of them have the same dimensional features. I would like to measure up the whole handle. Oh yeah, we already saw that in there. So I don't know if our comment section stopped working. They have stopped working. Yeah, exactly. And a canvas could be useful. Yeah, I guess that's the other side of it too. Is if you can find a profile of it, grab that screenshot and then just trace it out. That's actually probably
definitely. For
complex surfaces, that works really well. And then you can use, if you need splines, you can use splines. Or
I think so. I don't think he's talking about. I think he's just talking about like a kind of fancy ergonomic screwdriver handle, X driver handle. Yeah, I would just kind of mess around with a bunch of canvases, try and get a front and then a top view with like a ruler in place, and try and get as accurate of a shape as possible, and then print it out. If you are 3D printing and you need, don't forget about the funky setting fuzzy skin, which is how you can get kind of a grippy textured surface on Canva, or sorry, on Cura, excuse me.
Yeah. So, and Aaron says complex curves are another matter, but a set of radius gauges can be helpful. Yep, that's true. I don't use radius gauges all that much. I tend to, like Jake said, I tend to also do the same, where I find the dimensions I'm looking for, or I take a photo and I trace. But radius gauges, at least in person, can work, or when you have the object with you, can help.
Yeah, there's a really funky thing within manufacturing where if you have a radius gauge that isn't super duper well manufactured, it's like 3D printed or laser cut, it's not made out of absolutely perfect material designation. If you put it up against a radius and it 99% matches, then it's going to be fine, because the designer of this is not going to pick a radius that is 4.99 millimeters. They're going to choose a radius that's 5 millimeters, So if there's something that isn't exactly perfect, assume that it's going to be more of a neat number, a neat value, than something that's kind of weird.
So we have a couple minutes left here. I wanted to say that next week, Jake and I are planning to explore one of the workspaces that we haven't talked about. We're going to look around at either the sheet metal or maybe the surface modeling.
The surface, yeah.
Maybe the surface modeling, yeah. And we're going to play around a little bit, maybe live. So we'll do a little bit of work beforehand. But we haven't taught any of those things yet. Those are two of the most asked for areas of Fusion 360 that we haven't touched. So next week, we're going to play around with those live. Hopefully do a little bit of research.
Note, I do not have a lot of experience with either one. This is something that I definitely want to get more experience with. One of the things that a big part of the community that's reached out to us that we definitely are hearing is that you guys want to learn more about surface modeling, print in place models and how you would design that, and just a few other subjects that are a little bit more advanced that aren't covered in that. We are planning on coming out with an advanced CAD class where it's not quite as thick of a book, maybe half the size, as well as a 6-week course that would go along with it. So if you guys have any big subjects that you would really, really love us to dedicate an entire section on in Fusion 360, we'll definitely look into it. Circuits is absolutely something.
Maybe. I think I need to cut my teeth on circuits a little bit more before we feel comfortable diving in. Maybe what we'll do is partner with somebody who knows it well, though. To write those chapters.
Yeah. But we definitely have some good stuff coming down.
It says, I posted a link, but it's not working. I'll give it another go this week. Yeah, just post a link in anytime we have that announcement section in the Discord. Just go ahead and post your questions in there, post your links in there. I have the Discord actively up. So the announcement section of Discord or the general discussion section of Discord, great place to ask us to answer questions for the following week. We will be back in business. Maker Faire, we look for a special live session, probably Friday, Saturday, Sunday this weekend, something like that. Maybe we'll interview some people. We don't really know what it's going to be, but we're going to try to show you guys around Maker Faire at least a little bit at some point, and we'll hopefully warn you at least an hour before, but maybe a day before.
Yeah, we'll be posting a bunch of really good content, some videos, some pictures of Makerspace or a Maker Faire. So a bunch of cool stuff. So if you guys aren't following us on Instagram at CAD Class,
the IG official, or the Twitter
X as it is now,
the Twitter, Insta, YouTube.
So
give us a like, give us a thumbs up if you like this. As usual, super fun. Thank you so much for joining us on the CAD Class podcast. Again, I'm Josh.
I'm Jake.
And we will see you next week.
Adios.
Cheers, everybody.
Cheers. Peace.